in these sets, in this set of questions, we will explore what happens to the magnetic flux and the EMF as a loop rotates in a magnetic field. So this is the loop. We are looking at it from the top. This is one of the top of one of the wires. This is the top of the other wire. So think of a rectangular loop that's rotating in this direction, the way omega is shown. So this end is moving with a velocity v at this instant, while this end is moving with a velocity v in the opposite direction. At the instant shown, the blue lines are the magnetic field lines, and the velocity is making an, not the velocity, what's important is the normal to the loop is making an angle of 30 degrees with the magnetic field. They are asking us about the flux at the moment shown. Is it increasing, decreasing, or not changing? Okay, now when do we have a maximum flux? We have a maximum flux when the magnetic field and the normal to the loop are parallel. That's basically if my loop is like this and all the magnetic field is perpendicular to the plane of the loop or parallel to the normal to the loop. So in this case, what's happening, the plane of the loop is getting closer and closer to being parallel with the magnetic field. So instead of having a huge magnetic flux like this, it is turning towards the situation where we have no magnetic flux. So obviously then the answer is decreasing. The next question is, at that same position, what's happening to the EMF? Is it increasing, decreasing, or not changing? Now remember, the EMF is minus delta phi over delta t. You know, of course, you have n if you have n loops, etc. Now, pay attention to the minus sign. So if my flux is increasing, the minus sign is going to tell us we have a decrease, and vice versa. So actually here then, since my flux is decreasing, we can say that the EMF is increasing. Mathematically, it's a little bit easier to see it if we have the math, because actually this delta phi over delta t results in a sort of derivative. So you have a phase difference of 90 degrees between the flux and the EMF. But without getting into that, it is pay attention to the negative sign. But then let's look at it a little bit more thoroughly. Okay, now in here the question, at which time does the loop have the greatest EMF? Thinking of the same situation that we discussed a moment ago, which one has the greatest flux? Of course, it's 1. The least flux, it's situation 3. So from here, we figured out that the flux is decreasing and the EMF is increasing. So if the EMF is increasing, when is it going to be the largest? Obviously the answer then is here. Let's see why is it the case more thoroughly. Okay, in this case we have maximum flux, we have the most field lines going through the loop. Remember, the EMF is given by this expression for a loop rotating with an angular velocity omega and a magnetic field B, where A is the area of the loop, B the magnetic field, and theta is the angle between the normal of the loop and the magnetic field. So in this case, if we look at the equation, we have a maximum flux. My EMF is 0 because my angle theta is 0. In this particular case, my angle theta is 90 degrees, giving me an EMF of omega AB.